So now we are learning about reference angles. So if I just give you a general angle theta and you were to graph the general angle theta, the reference angle to it is how far that angle would have been from the x-axis. So if you were drawing a theta that existed in quadrant 2, this would have been your theta. The distance to the x-axis, which we're calling theta prime, the reference angle would have been the distance from the angle back down here to the x-axis. So if you're looking at quadrant 3, the only way to be in quadrant 3 is if you went all the way through the other two quadrants and then you're stuck halfway through the third. So this would have been your terminal side. The distance from him to the x-axis is going to be our reference angle. We call it theta prime. And then same with quadrant 4. Quadrant 4 meant you went through all three of them and then you stopped in the fourth quadrant. So this right here would have been our terminal side. The distance from that side to the x-axis is our theta prime, our reference angle. Notice that these green angles are always going to be acute and they're always going to be positive. You're going to need to remember that this side of the x-axis is pi, or it's 180 degrees. That this side of the x-axis is 2 pi, or it is 360 degrees, or it could also be considered 0 degrees, because you went from 0 all the way to 360, or you went from 0 radians all the way to 2 pi. So these are the two x-axes that you're going to have to remember. So we're being asked to sketch the particular angle. So my angle is a radians, so let's get our xy axis going. And I need to figure out which quadrant it's going to live in. So we have quadrant 1, 2, 3, 4. This side of the x-axis is both 0 and 2 pi. This y-axis, the 90 degrees, is pi halves. This is pi, and this is 3 pi halves. So we're trying to figure out where is 5/3. Well, 5/3. 5/3 is bigger than 1. So I know that it's not going to be inside of quadrant 1 or quadrant 2. It is bigger than 1, but if it exists over here in quadrant 3, then you are telling me that 5 halves is smaller than 3 halves. Well, what is 5/3? 5/3 is 1.6666. What is 3 halves? 3 halves is 1.5. I know that my given angle is going to be bigger than the 3 halves, so it will not exist in this quadrant, which means it has to exist in this quadrant. 2 pi. 2 pi is 2. This is smaller than 2, and it is bigger than the 1.5. So we know he has to exist over here in quadrant 4. So let's just go ahead and draw it. So 5/3 pi went all the way around, and it stopped somewhere in here at quadrant 4. So here's 5 pi thirds. Now we need to find the reference angle. The reference angle is the distance from the line we just drew to the closest x-axis that you have. So this is theta prime. This is our reference angle. We need to figure out how big this is. So to figure out what our reference angle is, the distance from 2 pi to 5 pi thirds. So the distance from 2 pi to 5 pi thirds. Well, if this is a fraction, you need to make him a fraction. So 2 pi is the same thing as 6 pi thirds, because 6 divided by 3 is 2, and now they each have the denominator of 3. 6 pi minus 5 pi is 1 pi, and the denominator 3 stayed the same. So the distance right here is pi thirds, so that was my reference angle. So we're being asked to sketch the angle. We have negative 130 degrees. So here is my xy axis. Quadrant 1, 2, 3, and 4. Negative 130 degrees means that I'm going backwards. So starting here, if I had gone all the way, this would have been 90. Going all the way again would have been another 90 to be 180, which is too much. So I know I exist somewhere here in quadrant 3. So this is my negative 130 degree theta. I'm being asked to find the reference angle. The reference angle is how far away that line is from the closest x-axis. So theta prime is our reference angle. Well, I know that this right here is supposed to be 180 degrees. What is this line? Because I went backwards, it's kind of a little hard to find. So I want to know what was this root this way if I went to the positive. Well, negative 130 is the same thing as positive 230, because total, they would have made a full circle of 360 degrees. So this was a full 230 degree, because this is the same thing as 230 degrees. What's the distance between the 230 degree line and the 180 degree line? What is my theta? So my theta is the distance from the 230 degree line from the 180 degree line. So 230 degrees minus 180 degrees gives me 50 degrees. So this theta prime right here is 50 degrees. He is my reference angle. So we're being asked to sketch the angle, negative 220 degrees. So we need an XY axis, quadrant 1, 2, 3, and 4. Negative 220 degrees means it goes backwards. So if I went backwards, that's 90. Another 90 would have been backwards 180. If I went another full 90, I would have gone backwards 270, which is too much. So I know I end somewhere in here in quadrant 2. So this is negative 220 degrees. I'm supposed to find the reference angle, which is how far this is from the closest x-axis. Theta prime is our reference angle. Well, this isn't a positive direction, so sometimes it's a little hard to find. So if I had gone the positive direction instead, this line is the same thing as saying I wanted to go a positive 140 degrees, because 220 plus another 140 would have gotten me my full 360 circle. So this line right here is the same as 140. So if I went 140, but I wanted to know how far away was it from the 180 degree. So my theta prime, my reference angle, what is the distance between the 180 degree line and the 140 degree line that I was given? So I get 180 minus 140 is 40 degrees. So this reference angle right here is 40 degrees. So we're being asked to sketch the angle. If you're sketching the angle, then you need an XY axis that labels the quadrants, quadrants 1, 2, and 3. Now I need to figure out where 15 pi 16ths is. Well, this right here is pi halves. This is pi. This is 3 pi halves, and this is 2 pi. Those are our 4 kind of identifiers. So I need 15 pi over 16. 15 over 16 is really close to 1, but it's still smaller than 1, which means we know that we are really close to the 1, but not bigger. We're still smaller than 1. So we know that it exists somewhere over here in quadrant 2. So all of this right here is my 15 pi over 16 theta. I am being asked the distance between that line and the closest x-axis. So theta prime is my reference angle. So what is the distance between the closest x-axis, which is pi, and the line I gave you, which was 15 pi over 16? Well, if you have a fraction, he needs to be a fraction because we're denominator 16. This is going to be 16 pi over 16 because 16 divided by 16 is 1. So 16 pi minus 15 pi gives me 1 pi, and we're talking about denominators of 16. So this is my reference angle. The distance between this 15 pi 16ths and the x-axis closest to it is pi all over 16.